Hello everyone, this is Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering, Coimbatore. So in the last video we discussed about IPESP. So in this video we are going to see about IP authentication. So this video will cover what is IP authentication and authentication format and advantages and disadvantages of IP authentication. So in the last video we discussed about IPESP, that is encapsulating security protocol. So in this there are two modes of operation, and we discussed about the format for IPESP. So in this video we are going to discuss about authentication header. So first let us discuss what is authentication header. So the authentication header AH is a security protocol used within the IPsec suite. So IP security suite. Its primary is to ensure that the message remains unmodified during the transformation from the source, and it confirms that the data originates from the expected source. So that is the main authentication. Header achieves this by adding a header to IP packets containing a checksum and a digital signature. So its main functions are message integrity, that is the message is not modified while coming from the source. And source authentication means the source is exactly the source from whom we were expecting the data. So when a packet is sent from the source A to destination B, it consists of data that we need to send and a header that consists of packet information. So the authentication header verifies the origin of data and also the payload to confirm if there has been modification done in between during transmission between source and destination. However, in transit, values of some IP header fields might change. For example, hop count, options, extension headers. So the values of such fields cannot be protected from authentication header. The authentication header cannot protect every field of IP header. It provides protection to fields which are essential to be protected. That is, it provides protection to the data. So this is the header format, authentication header format. So it consists MAC header, IPv4, IPv6 header, that is authentication header payload. So authentication header consists next header, it is 8-bit, payload length, it is also 8-bit, and some 16 bits are reserved, and security parameter index is fixed for 32-bit, and sequence number also 32-bit, authentication data also 32-bit. So next header is an 8-bit field that identifies type of header present after the authentication header. So in case of TCP, UDP or destination header or some other extension header, it will store correspondence IP protocol. For example, if it contains 41, it will indicate IPv6, and a number 6 will indicate TCP. 4 indicates IPv4. So payload length, next one is payload length. Payload length is length of authentication header, and here we use a scaling of factor 4. Whatever be the size of header, it is divided by 4 and then subtract by 2. So this helps in determining where the payload starts. And reserved 16 bits field which is set to 0, reserved for future use. And security parameter index SP, it is arbitrary 32-bit field. It is very important field which identifies all packets which belongs to present connection. So hashing function is a cryptographic algorithm that converts input data any size into fixed size of string character which represents the original data uniquely. So here we are using Diffie-Hellman algorithm. It's a method for securely exchanging cryptographic keys over a public channel is used. So hashing algorithm and a secret key for a security parameter of connection will be fixed before data transfer starts. Security associations need to be established. And the next one is a sequence number. So this unsigned 32-bit field contains counter value that increases by 1 for each packet sent. So every bracket will need a sequence number. It will start from 0 and will go up to 2 power 32 minus 1. So the next one is authentication data, that is integrity check value. So authentication data is variable length field that contains integrity check value, that is ICV, for packets. So using this hashing algorithm and secret key, the sender will create message digest which will be sent to receiver. So receiver on the other hand will use same hashing algorithm and secret key. If both message matches, then receiver will accept data. Otherwise, the receiver will discard it by saying that the message has been modified in between. So basically, authentication data is used to verify the integrity of transmission. Also, length of the authentication data depends upon the hashing algorithm what we are choosing. And the next header is a 8-bit field that identifies the type of header present on the field. So hope this video will help you to understand what is authentication header. Thank you.